Hello everyone. Today we are going to see about the left ventricular pressure volume curve. So before going into the curve, let's see. So in the left, here we have to plot the left ventricular pressure in a vertical axis and the left ventricular volume in the horizontal axis. So to start with, let's start with mitral valve opening. So once the mitral valve opens, what will happen? All the blood from the left atrium will enter into the left ventricle, right? So the left ventricular volume will actually increase. So it will go around about 150 ml. The left ventricular volume will increase. Once the left ventricular volume is increased, the left ventricular pressure will also start to rise, such that it will be much higher than the left atrial pressure, such that the mitral valve will close. Okay, when there is a pressure difference, then the mitral valve will close. After that, now the mitral valve is closed, aortic valve is also closed. Now since the left ventricle is already full, it has to now pump all the blood that is already present in the left ventricle into the aorta. But the aorta is already also closed, right? Aortic valve is also closed. So what happens? It will undergo an isovolumetric ventricular contraction. During that phase, the left ventricle will contract and the pressure will increase. Okay? So this is the left ventricular pressure, right? So the pressures are increasing. The pressures are increasing to a point where the left ventricular pressure is much more higher than the aortic pressure, such that the aortic valve will open. So at this point, the aortic valve will open. Once the aortic valve opens, the blood which is present in the left ventricle will enter into the aorta, right? So if it goes into the aorta, the left ventricular blood volume will decrease. So here we are plotting from 0 to 150 ml, 0, 10, 20. So that's how it's been plotted. So the left ventricular blood volume is decreasing. It's fine. So but the aorta is getting filled. What is that called as? That is called as the stroke volume. Fine. After a certain amount of blood that is being passed, that is, after the stroke volume has been pumped into the aorta, the aortic pressure will become much more when compared to the left ventricular pressure. At that pressure difference, we will have the aortic valve will close. So that point, that is the aortic valve gets closed. So that is what? That is the end of systole. So this volume you can also call as the end systolic volume. Having said that, in this context, I want to tell you something. Here where the mitral valve opens and all the blood from the left atrium, it will enter into the left ventricle, right? So the left ventricular blood volume also increases. Now the mitral valve closes. So what does it mean? It is at the end of the diastole. So this volume is called as the end diastolic volume. So at this point, that is after the aortic valve closes, the ventricle is now supposed to go into our next phase, that is the diastolic phase. So before the actual ventricular filling happens, it will go through a isovolumetric ventricular relaxation phase. So during that phase, the ventricle will begin to dilate, such that the pressures within the ventricle will also decrease because it is getting dilated. So the pressures are all decreasing. So this is known as the isovolumetric ventricular relaxation phase, and this is the isovolumetric ventricular contraction phase. So this is